Ladies and gentlemen, welcome back to another live stream. So today we're gonna be continuing our engine, and also I should probably change the title. It's no longer just about Ash. Hopefully it's gonna be a whole freaking engine, but yeah, whatever. Anyways, so let me share stream on Discord. Please join my Discord. You can find the link in the description, discord.kodotaku.com. So let's see, live. Alrighty, so I've done a lot of things off camera. I just couldn't wait, I couldn't hold myself. So I guess today we're gonna go through it. Pop out the chat. There we go. Alright, is the stream fine? I would guess so. Let's see, no drop frames, the mic is on. Everything looks perfect. Anyways, let's get going. Alright, so this is our project right here. Let's run this out and see for ourselves. Let's run it in RenderDoc so you can see the FPS and so on. Let's launch application. Well, let me just compile this for release real quick. Well, cargo b dash release. Oh. There you go. It would compile the whole thing for release mode. And then we can go to target, release, Control-Shift-C, and go to RenderDoc, Control-V, and then let's set the working directory, and let's basically launch this thing. And there you go. So this is what I got so far. Here we go. On my machine, with this scene right here, I'm getting around like more than 3000 FPS. With this scene, and I'm actually streaming, so that's pretty cool. Let me print screen, and I also added RenderDoc integration, so I could just say F1 and then it would capture. There we go. And let's go to some draw call here. Draw indexed. Well, actually not this one, my bad, hold on. Let's launch the application again. Let's take another capture. I took capture of the wrong screen apparently. Let's capture here, for example. Okay. There you go. Color pass, draw indexed. So this is the 2D color attachment. There you go. And this is the depth attachment. This button basically takes these minimum and maximum and like put them into the minimum and maximum of the image, so we can see the image in maximum contrast essentially, which is nice. The other thing is, let's go to mesh view, for example, and vertex output. So there's no vertex input because I'm not using the regular, vertex buffers like vertex bindings, but there is output, as you can see here. Let's show all instances because I'm using instancing, and there we go. So like this is the actual viewport. Let's visualization solid color, right click, and there you go. So this is the mesh that we're rendering right now. We're rendering 16 of them, 16 instances there. There you go. So that's pretty cool stuff. Alright. Alright, what did I want to show you other than that? I think we're good. Statistics, we have around 5 RTs, 10 megabyte, 7 buffers, 0.26 megabyte, I think, yeah. And then in total 10.33, I think, megabyte. Yeah, pretty much one draw call. Anyways, let's go back and see what I've done so far. So let's go to the repository, and let's go through the commits I've done. I don't even remember what is the latest commit that I've done in stream, honestly. Let me see. Expose rendering automated image. Buffer device, update some commands. I think I've probably done this in the previous stream. But yeah, let's just go through it from here. So I updated some commands, then I've made a circle with buffer device address vertex buffer. Then I moved in algebra dependency to engine. I automated image layout transitions. We no longer need manual transitions. I exposed the renderer properties of the application, added geometry and staging belt objects. Staging belt basically helps me stage geometry from, you know, the CPU memory to the GPU memory, right? So I added a depth buffer, cube, and a rotating camera. Instancing, I checked for required features. Buffer device after capture play is now optional. Oh my god, I really can't go through all of this now. That is crazy. Merge, add features, automate shader compilation, add RenderDoc integration. I guess let me just go through some of the highlights that I liked most, I think. So the first thing is the shader compilation. Right now it's automatic, right? So you just add in a shader in DevRes here, or if you change some shader here, it would automatically go ahead and it would compile them into the res folder here, into shaders res. And how that works, and also it have includes supported. So like I have this file right here, this GLSL file. I have included that into here, as you can see, and into here. It also handles that. Let me show you how I did that. I've made the build.rs file here, build.rs. There you go. I'm using the shader secret. So cargo rerun if change devres, cargo rerun if change res. So here I'm creating a shader compiler. Then I'm adding some compile options. So the first thing is the target environment, which is Vulkan 1.3. Source language is GLSL because it also supports HLSL. And I set to then include callback. This is what you need for the include here to work. So where is it? Hold on. There you go. Set include callback. You get the name, and then I go ahead and actually load that file from file system, and then I give it back that content, right? So it could basically replace it there. Is debug build? I check for the environment variable OPT level because this is the build script, not the actual code of the engine. And then if it's debug build, then I set the optimization level of the shader to 0, and I set generate debug info. Otherwise, I set the optimization level to performance. Then create directory all res shaders. I go through all the shaders inside of devres, and then I pick the extension, the file name, the shader kind, and then I read the file like source code, and basically I compile that to SPIR-V with the entry point name of course being main, and I just get the binary result there of the compilation, and then I write it back into res/shaders. And that's basically it. Nothing crazy there. This is very freaking useful. Like, let's say I have some problem here in my shader, so I'm gonna change this, for example, and then I run this, and it would give me the error right here. So error compilation error shader.vert in the line 8. it says syntax error and expected type name expecting left brace. You see? But if I fix this here and then I actually try to compile the engine, it works. So there you go. I'm very proud of this system. But anyways, other than that, what else I've done? Yeah, the automatic layout transitions, I also found that pretty cool. Let's go to, where is it? Hold on. Render commands. Yeah, let's go to the render, right? For example, or actually let's go to the window render first, maybe. Yeah, and let's go to the commands. So where I'm doing the commands, so where is it? There you go. So commands.blit full image, render target, swap chain image with SSA. Yeah, I also added SSAA, like super sampling into aliasing, right? This is just like basically a resolution scaling. I'm gonna show you what it is in a second. And then I have transition image layout. This is the only manual transition layout transition I have, which is for presentation, because like that's outside of the scope of the command buffer recording. So I can't really predict if that would happen or not. So that's manual. But the other ones, like for example, making the render target source for the blitting and so on, that's no longer, that's automatic. And let's go to the renderer too. So the render function, well, let's see what we got here. Commands.begin rendering. Remember that we had like a transition here for that, and we no longer need it. And the draw function here, all good. Anyways, let's see how I actually done it. It's pretty simple, really. So if we go to commands here, so let's see. So I have this function called ensure image layout, right? So it basically checks if that layout is a subset of the old layout. So if the new layout is a subset of the new, if the new state is a subset of the old state, if that's the case, like if it's not the case, then we're actually going to transition the image too simply. Now here, for example, the blit image command, we have self.ensure, so basically the commands.ensure image layout, source image, transfer source, and ensure the image layout of destination image as transfer destination, basically. And then we do in the command blit image. So it's very simple, nothing fancy. Same thing with begin rendering. We ensure the image layout of the render target to color attachment and the depth buffer to depth stencil attachment. And yeah, I did add the depth buffer too, of course. Let's see what we got else. Yeah, that's basically it, I think, here. What else I wanted to show? Frame buffer, in-flight fence. Let's go to the commits. Clean up your shaders. Yeah, I also added RenderDoc integration. So like if I go to the engine library, right, you're gonna see that I have right now RenderDoc here as an option. So I say RenderDoc new.ok. Now you gotta have the RenderDoc DLL in your path. So like, hold on, RenderDoc DLL. Oops. There you go. Open file location. Oh boy, I don't really know what the heck is going on there. Let's just try to find it myself, I think. So maybe program files, RenderDoc, there you go. So you have a DLL here. Here you go, RenderDoc.dll. You should add this to your path. right? And so basically what happens is when you launch the application or the engine from RenderDoc, this actually would load and it would be okay RenderDoc, right? So it would say RenderDoc is available basically. Then what you could do with that, you could actually trigger, like programmatically trigger captures of RenderDoc, right? So for example, here, the only place where I actually use that is, so like when I actually click on PRT screen, it actually gives me this capture thing, which slows me down. So instead of that, I just set it like a new key for it, like F1 here. If event.state is equal to pressed, then I check if we have RenderDoc. If we have it, then we trigger the capture. That's kind of neat. What else? Let's see. Add feature includes fix some best practices. Also, of course, I added instancing. Depth buffer is just like create a new image. Nothing crazy there. And yeah, the staging belt is also quite interesting. Let me show you that staging belt. So it's basically just a buffer, and it have a write cursor and a copy cursor, which is just like an index, right? Or a value, right? So just U64, I think. Yeah, there you go. So when you say new, it just creates a host buffer, like a buffer that exists on host memory, but that is readable from the GPU, right? As you can see, CPU to GPU. And of course, transfer SRC because we want to copy its contents to the GPU buffers, right? Now we have a write function with a generic T that needs to have bytmark POD, plain old data basically, and we have here data slice of T. Then we essentially get the size, data length times, so basically the data's byte size, right? So self.buffer.write, then we write the data to it, and we like the offset, of course, is the write cursor, and then we advance the write cursor by the size in bytes of that data. That's the first thing. The second thing is copy to. So this gets a buffer and the commands, right? And then it basically adds a command called copy buffer, and it basically like copies this buffer right here, so the staging buffer, to that buffer, to that destination buffer. And of course the offset is copy cursor, and then we advance the copy cursor by the buffer size. And we have here stage geometry function, which make use of these two commands, right? So I have another instance called GPU geometry here, and of course we get an instance of commands. So GPU geometry is just like geometry, vertex buffer, and index buffer. Geometry is just like vertices and indices, pretty much, nothing fancy, and that's the vertex that we had before. So yeah, now here we have self.write, so the staging buffer, right? .write, we write the GPU geometry.vertices. So basically geometry just contains the actual data of the geometry, but like GPU geometry contains the buffers too, right? So here GPU geometry.vertices, then we copy that to the vertex buffer. So we copy the vertices and we copy it to the vertex buffer, then we write the geometry indices, then we copy that to the index buffer. So instead of like creating a new staging buffer for every single buffer, like GPU local buffer, we actually just use one staging buffer, and yeah, there you go. And we have a done function here that basically resets these cursors, so if you want to reuse this staging buffer here, basically. Now let's see where I'm actually creating this. I'm creating it here, right? Here I'm setting the size to GPU geometry size, geometry size as vacant device size plus the instance buffer size, because I also have an instance buffer there. So here staging belt.stage geometry. I staged the GPU geometry that I loaded beforehand, and then I write to the GPU instances buffer. Sorry, GPU instances like data, and then I copy that to the instance buffer too. And then I say .done, right? I also added cameras, of course. So this is the instance buffer here. This is the GPU instances. So GPU instances is just instances, and we iterate it and we map it to GPU instance here. So yeah. Here I'm generating some instances in a grid, right? So this is kind of like a nested loop, -2 to 2. And then we have instance new, NA vector 3 new. Yeah, and then we rotate it using unit quaternion from axis angle. Because the model was like rotated wrong, in the wrong direction. If we actually go here, it's pretty simple really. You just take the position, the rotation, and the scale. And then the transform is an affine 3. From matrix inject, it's basically a new translation. Position times matrix 4 from rotation, and times matrix form new non-uniform scaling. As you can see, it's pretty technical when it comes to an algebra in like your regular, math library. Rotation is a unit quaternion, not just a regular quaternion. And affine 3. Let me show you how you can actually understand this stuff. If you look for an algebra, right? Where? Not here. Whoops, an algebra. And I think, yeah, get started. And then you go to, I think, the points and transformations, or maybe. Yeah, here you go. So this diagram right here. Hold on, can I open that image? There you go. So this diagram is very useful here. So here we have translation 2 or 3, pure translation. And then we have rotation 2, 3, or unit quaternion or unit complex. This is a pure rotation. And then we have an isometry 2 or 3. It's a composition of rotations and translation. So no scaling basically, only rotation and scaling, like only translation and rotation is called an isometry. If we add uniform scaling, then we get a similarity. So, and if we add to a similarity non-uniform scaling, then we get affine 2, 3. So this is the one that I actually used because I do need non-uniform scaling. So projective 2, 3, this is an arbitrary invertible transformation. So if we add invertible operations, basically invertible matrix operation, then we can get a projective. If we also add non-invertible operations, then we actually get a transform and a matrix or a matrix. So these things are basically just more constrained matrices, like, and why we need that? Because like you can optimize a lot of stuff if you know that you have some constraints. So like some operations, let's say on isometry, could be optimized out like more than a matrix, because like if you just get a matrix with no constraints, then you can't really assume anything. Like you can't assume that it's invertible, for example, or whatever. But like if you get a projective, for example, you can assume that it is actually invertible matrix, so you could do some optimizations or whatever. So yeah, that's pretty cool stuff. I recommend checking out the other stuff that they have here. Pretty cool. Though I did rely a lot on, like, what is it called? GitHub Copilot to help me with this stuff, honestly. But yeah. Anyways, let's go to, so that's the GPU instance. So the GPU instance is just a regular matrix, as you can see, matrix 4. But the actual instance that we have is an I find 3. GPU camera is just a matrix for the view, matrix for the projection, and a position vector. While here, the actual camera here, we got an isometry 3, so only translation and rotation, no scaling. And then a projection in a perspective 3. So that's in a like in algebra basically in a nutshell, I guess. So here camera we're using oopsies, how can I close? Here we're using NA isometry 3. Look at right hand side, like right hand coordinates. So we got the eye, basically the position of the camera, the target, like where the eye, like where the camera is looking at, and then here the up vector too simply. And we also got the projection here. Projection is like you just give it the aspect ratio, the FOV, the field of view, and the z near and the z far. So yeah, view projection to GPU camera. So yeah, that's I think about it for maybe let's check out a bit about the shaders. Why not? Let me show you a bit about the shaders too. Where can I digress? Right there you go. Okay, cool. So let's open up the vertex shader first. And let's see. So of course we're getting our data from, you know, the buffer device address stuff from the push constants. Like the push constant contains addresses to buffers, and then we access those buffers, and then we get our instances and vertices and so on. Anyways, here we construct an MVP matrix, a model projection view matrix. So we just multiply the projection matrix with the view matrix, and then we multiply that by the the model of the instance. So like that's basically it. And then here we have GL position is equal to MVP times the vertex position. By the way, there could be some errors here. I'm not the best at mathematics. But hopefully not. If so, please, like you can just go to GitHub and file an issue or even a pull request. But anyways, frag position, here we got some out variables is equal to vector instance dot model times vertex dot position. Here the normals. So basically to like fix the normal, like basically to transform it the same as the model, we have to do this weird crap right here. Like you transpose the inverse of the instance model matrix, and then you normalize the normal matrix times the vertex dot normal. Crazy stuff there. Anyways, so the fragment shader. Okay, let's see. Currently I just have the light direction and so on, just like, you know, just hard-coded for now, but later on I could put it in its own buffer and stuff. Anyways, so we got some sun direction, specular string, and ambient. We get our camera position because we're gonna need it in the like the specular calculations. So here we have a diffuse. If you want to learn more about this stuff, I recommend, by the way, here's the link for this one. For the other one, let's go. So there's two things, but let's just learn OpenGL. This is quite good. Like if you go here, go to lighting, and you go to basic lighting, you can see, so this is the ambient, this is the diffuse, this is the specular, and this is the combined Phong model. Phong like lighting model. Okay, so this is the diffuse, right? So you have the normal, and then you have the light direction, and so, and we use that to basically calculate the light. So this is it. And this is the thing about the normals. You could read through this. There you go, transpose, inverse, blah blah. specular lighting. Though there is an optimization, like if you know that your model would have uniform scaling, then you can do some optimization there. But anyways, specular lighting, it depends on the camera position, that's why I stored it. So yeah, it's basically the reflection there. All right, so I guess that's it that I want to show you today. Is there anything else? Let me see. And depth buffer, add geometry. There is nothing crazy in geometry. I'm just using the TOBJ like library for loading OBJ. I'd like to support, you know, what is it called? The newer format. Oh boy, forgot the name of it. Anyways, so a lightweight OBJ loader, this is what I'm using. Let me show you actually. So if we go to geometry here, we do need a new struct called model, which is going to contain multiple geometries, but for now we don't. So load objects, currently I'm just ignoring the materials, but we're actually going to work on that soon. So here we have mesh, and I'm just getting the first model. I'm ignoring the other models for now. And then here the vertices is mesh.position. So basically the mesh contains the attributes like in arrays. So like the positions in one packed array, and then the normals in its own separate vector and so on, right? So here I'm basically chunking that. And also I think the X and Y and Z also are separate. So here I'm basically taking the positions, like separating it into 3 chunks, and then I'm zipping it to mesh normals, and of course that also gets separated into 3 chunks again, because basically all the components are also separately stored for some reason. And then we map those, we get the position and the normal. And yeah, that's basically it. So we get the components in the right place, and that's pretty much it. Hello Loop Luminary, welcome back to livestream. How's it going? And the mesh indices, nothing fancy. We just take the one that is stored there, which is great. Create GPU geometry, again, nothing fancy, just a vertex buffer that is a GPU only, that is stored in the VRAM, right? That's why we need the staging buffer, because we can't access it from the CPU directly. We have to stage it using another buffer, right? So that's pretty much it, nothing crazy here. Is there anything else that I want to show you? Let's see. RenderDoc, actuator includes. Geometry expose. Oh yeah, the resolution thing. Yeah, the resolution scaling. That's also very interesting. I'm gonna show you that too. Move the image related. Yeah, I think that's the last one that I'd like to showcase. The other ones you can just check my commits and see exactly what I've changed. And you could check the other sources that I've listed here in the chat for more information on how that all works, so we don't waste too much time. All right, so yeah, let's actually go to that. Let's see, where did I put it? It's probably in the render, I think. No, let's actually go to the application. Yeah, let's go to the application. Here we go. Cool. So now I actually exposed the properties to the application. I'm gonna expose more properties. There's a lot of other properties that I haven't exposed yet. It is because, you know, I was fast making features and so on. But anyways, so right now from the actual application perspective, you could set all these properties. You could set the format of the renderer to whatever you want. It doesn't depend on the swap chain. Well, of course, as long as the physical device supports it, but you got the point. So for example, here, so like usually the swap chain is only just 8 bits in like 8 bits in the color. So like you just have 256 distinct colors to use, you know. But here I'm actually using a 32-bit color. So, well, actually no, hold on, what the heck? Is this like a 32-bit or, bro? Hold on. Let me just make sure. What is the bit depth of this? Is it 64, 32? Probably 32, but like, hold on. What is the bit depth of this? (64), yeah, 64 bits per pixel. So 16 bits for every channel, like for the red channel, for the green, blue, and alpha channel. And of course, we were using sfloat, you know, so like a value from 0 to 1, decimal. Well, not exactly decimal, but you got the point. Anyways, depth format. Here we're just using D16 unorm. So 16 bits for the depth. If you need more, you could use more, D32 if you want, or whatever, but it's probably an overkill. And then the clear color. This is like what you want to clear the screen to. And this is the interesting thing that I wanted to show you, SSAA. It's kind of similar to MSAA, but not the same thing. And then we also have an SSAA filter. And then I also exposed the in-flight frames count. So yeah, let me show you this. So as you can see, the secondary window actually have an SSAA of 0.1. That's why the second window have a lower resolution, right? So that's basically the resolution scaling. So this is the resolution scale of 0.1. So basically every 10 real pixels is 1 pixel in that renderer, right? As you can see here. But of course, if I make it 1, it would be just like, so every real pixel would equal 1 render pixel. So both right now are rendering in full resolution. Though, let's say you could also, now the real super sampling into aliasing is when you actually make this more than 1. So like if you say 2 here, and let me actually like build this for hold on. Let me actually build this, right? And let's go to RenderDoc really. And so I can show you what's up. So we have one window have an SSAA of 2 and the other is 1. Let me show you. So let's just go with debug. It doesn't matter. Blanch, no. Alright, let's take a capture of the primary window. So one of them is actually having this like double the resolution of the rendering. So how big is this? Hold on, color pass. So this is 1600 times 1200 resolution. But the actual window is just like 800 times 600, so like double the resolution essentially. And of course the bit depth of the color is way bigger. But you got the point. I should also, like, if this is basically HDR, but we still haven't implemented some things to actually call it HDR. Like we need to implement tone mapping. We're probably going to use compute shaders for that at the end of the render pass, right? The rendering pass. But for that, we're going to need to set up the bindless textures or just use descriptors and so on, which I haven't yet. And honestly, That's like, I'm really procrastinating for that because I just have no clue I'm gonna set that up, and there is not that much resources about it, but hopefully I could figure it out. But yeah, so yeah, that basically allows you to scale the resolution. And of course the nearest here, the filter. So basically when you have, let's say 0.1, let's say in the second window, for example. So this is what you get. This is the nearest filter. So it just takes the nearest color of that pixel. But if you go ahead and like, what is it? If you make it, there is another one called linear, then it would actually interpolate the colors to make up the newer pixel. And there you go, this is what you get in the linear filter. So yeah, nothing crazy, but that's cool. Okay, I think that was all I wanted to show you for now. At least like these are the highlights, but I actually done way more than this, especially in the architecture and so on, but whatever. So yeah, and honestly, let's just keep this as 1 so people don't think it's a bug. So yeah, is there anything else? Let me see. Buffer image. Yeah, the other stuff is just boring stuff, you know. So I think let's add something, I guess. Yeah, let's add some other feature now. Let's add MSAA. So we can have some smoother, like if you actually check here, like this is not very smooth, you know, there's jagged edges, right? So the edges are jagged because there is no smoothing. So let's add some smoothing there. Like you can actually have a smoother result by just, you know, scaling the resolution twice. So like rendering twice the resolution of the window, but that's too costly, you know. And it's not as good as MSAA, at least it doesn't seem like. So let's actually do that. So for that, we're gonna need to add like another render target for resolving multisampling. So let's see how we're gonna do that. Window renderer. So let's go to our renderer. Where is our renderer? Here we go. And let's add a new image here. So we got the render target and we got the depth buffer. So let's add the MSAA. What should we call this? Render target? Okay, fine, that's good. MSAA render target. Now let's actually, so we have an error here. Let's check that out. Where is it? There you go. Okay, so now we need to actually create the MSAA render targets here. Let's go. So new MSAA render target. Yeah, let's create the associated function in the image here. Let's actually remove this crap from here and put it yeah, let's put it inside of the image. Oh boy, that's a lot of code. It's pretty much like more than 2,000 lines of code so far. I mean, let me show you. If you go to where I think here. And if you go to the RS, here you go. Oh no, that's too much. What about, maybe we do, well, let's go to the source the directory of the engine, okay, and let's refresh on that. Okay, so here's the Rust files. So the maximum lines of code in a file is 470. The minimum is 75. The total lines are like 2,438. But without the spaces and like without the empty lines, you have 2,159 lines of code. That is crazy. And 10 files, pretty much, 10 Rust files in the engine alone, though the app doesn't really have that much, really. So yeah. Anyways, let's continue. So here we got the context, the rendering context. Here we got the allocator. And what else here we got? I think the name, probably. Yeah, I would guess the name. And then the extent 2D, that's, well, pretty much the extent, the format, and P5 is probably the sampling count. I think so. But we probably want vk sample instead here. Sample count flags, yeah, there you go. So that's basically how much samples. I do want to make all these parameters into their own struct, honestly. That would be nicer. But anyways, let's see if GitHub Copilot would do a good job here. I also, by the way, added another extension for allocation priority. So basically you can give a priority to the buffers and images and anything you allocate, like any allocation you allocate, and it would basically determine, like, the priority determines which allocations are more important than the others should be in the VRAM. Because like if the VRAM is not enough, then what the OS or the operating system would do is that it would page out those memories, like those allocations to the system memory, so they would be in the RAM, right? Which is going to be very freaking slow to write from the GPU and to read if that happens. So basically here you give a priority, so the ones with the bigger priority or like the lesser priorities gets to be paged out first when the VRAM is not enough. So that's basically, though currently I'm not really using it. I just actually implemented this because there was like a best practice warning from NVIDIA, I think, to implement it. But currently I'm just setting all the priorities to 1. So I'm not really making use of it yet. Let's do this. So basically, where is it? Yeah, so I was like enabling best practices here, and so that like popped up, right? So I implemented it. But yeah. Anyways, so here what we got. So of course it would be GPU only, so VRAM. Color attachment, transfer source, yeah. Transfer source. So the render target then would need transfer DSC, correct or no? I mean, it's already transfer source, yeah. But hold on, no. We'll see. Anyways, we'll see. So is there anything else? What about the samples? We probably don't include that. Yeah, there you go. So we're gonna need this, basically. And yeah, let's add that to the image attributes. So attributes dot samples. Well, let's just add that manually then. Attributes public samples. And so let's actually open up the tutorial real quick. So let's look for Vulkan tutorial MSAA, just so I can make sure what I'm doing here. Though they're going to be using render passes, but we're not using render passes, we're using dynamic rendering, so this is going to be a bit different. So here first they're checking the support for that. We're not gonna do that, at least for now. Setting up a render target, that's what we're doing. We're gonna need to add it to the pipeline, of course. But like, create the image with MSAA samples, huh? Swap chain extent dot width dot height. Transient attachment bit and color attachment bit. I need to add that one and create an image view. Color format. So yeah, I think let's just try and see what's gonna happen really. Yeah, let's go. So we got a new render target. Let's add the samples here. Just gonna be one, I think. Well, vk samples type 1. New depth buffer, same thing, of course. Nothing fancy there. But for new MSAA render target, you're gonna actually give it the samples, right? Cool. So here we need result. Yeah, correct or no? I think so. Yeah, result self. And there we go. Color attachment. I think here where we're gonna need to add, or maybe not. Let's see. Probably not. Maybe here then. Where the heck is that? Hold on. Vacate image usage. Yeah. So transient. I think if I remember well, it basically means that we don't care about the image content afterwards. I think. I mean, we can check it out. Transient attachment, or we could just like ask the AI. What is this? So transient attachment indicate that the image is transient attachment, meaning it will be used temporarily. Yeah, that's basically what I tried to say. May not need to be backed by physical memory. There you go, for the entire duration of its use. This is often used for images that are only needed for a short period, such as during a single render pass. That's basically it. All right, perfect. Is there anything else? I don't think so. All right, let's go back to where we're actually using this. There you go, cool. And here, let's set the actual samples, vk sample count. And why the heck it's saying type 1? What the heck? Let's say type 4, I guess, for example. It's private. Can you make it public, please? No, you can't. Okay, let's just do it ourselves. And there we go. Let's import. What the heck? Why this is having a problem? That's strange. I'm not sure what happened there. Anyways, probably some syntax error. But now let's actually zip depth buffers. Now we need to also zip the other one. I don't think we could zip multiple things though. But we could do something. Yeah, we could do something which is basically this is the that, and then here you're gonna get the MSAA render target, I think. Right, so let's call this depth buffer actually, and so we could just do this and add the missing fields. That's basically it. So right now we added that for every frame. Great. What else? I think right now it's the time to look into the, what is it? The pipeline maybe? I think so. Oh boy, we're using dynamic rendering, so it's gonna suck. Let's see if there's anything about it, by the way. Well, let's just go to the pipeline honestly and do ourselves. I don't think I'm gonna find that much information about it really. So let's go. Where is it? Render? No, probably the rendering context. Rendering context, and let's look for the create pipeline function. There you go, create graphics pipeline. And let's see what we got here. So down here in the vk pipeline render create info, we probably gotta add some new stuff here. Maybe. Doesn't seem like it apparently. I guess. Yeah. So where we gotta add it though? Probably in the begin rendering then. Let's go to the commands. Begin rendering. There we go. And let's see what are the options we got here. So image view, image layout. We got a depth attachment. And stencil attachments, view masks. So probably around here in the color attachment, dude. Dot. What? I expected to have some samples here or something like that. Really? For real? Oh, there you go. Okay. So inside of the rendering attachment info, we have a resolve image layout and resolve image view, basically. Resolve image layout and resolve image view. So let's actually add the image. So the render target, the depth buffer. Well, actually, instead of saying render target and depth buffer and so on, we could just say frame, really. So frame is, well, not frame buffer. We're just gonna get the render frame, right? And so we wouldn't have to always add another parameter. Okay, so here frame.render target. That's why I love like using structs instead of, you know, parameters. But anyways, though here probably mutable. Frame render target, expected mutable converge. And here we're gonna say frame.depth buffer. And honestly, same thing with the other ones. Whoops, what's going on here? Oh, yeah, let's just say frame dot render target. And there we go. Now here, where we're gonna have some new stuff. Dot resolve. No. Resolve image layout. No. What is this? resolve image layout. I'm not sure if I really understand this. Let's see if there's anything about it. Well, I guess we are probably on our own. I did implement it though before, though I don't remember how. Is there anything about dynamic rendering here? No. Yeah, let's just try and do whichever. So, hold on. Do I render to the, well, to the render target, then resolve to the MSAA render target, or the opposite? Let's see. Yeah, you should render to the MSAA render target first and then resolve it to the non-MSAA render target. This is because MSAA is used to improve the quality. So render to MSAA render target. Okay, cool. So that basically means that instead of render target here, we gotta use MSAA render target, right? And here too. So we gotta render to the MSAA render target. Pretty much, and then and then and then we resolve to the frame render target. Well, whoopsies, dot resolve. There's a resolve mode and resolve image view. So, oopsies, dude, come on, resolve. And what the heck is that resolve mode? Nope. What is it? Resolve mode flags. KHR. So there's average, max, min. Oh yeah. So I know what this is about. I think. Let's just, I guess, maybe go with average, maybe. So let me try to explain, at least from what I understand, how MSAA works. So basically, actually, I think the other one have better images for it. Maybe I haven't read through this one. I should probably do that. But I think this one have a better graphics for it, like better images. Yeah, there you go. Okay. So without MSAA, you basically have one single sample per pixel, right? You sample the color, you pick the color. So here it shows it as the center of the pixel, though I'm not sure if it's really required to be the center of this pixel, but anyways. Now here this is MSAA x4, right? So we have 4 sampling points. So in every pixel, we actually take 4 points and get the color in those points, right? And then we actually, depends on how much, we basically kind of like blend those samples together, right? And then we get, like, for example, we have this triangle right here, okay? Now let's say, for example, this pixel right here, it's only covered by 2 samples, right? Which means that this should probably be like 50% brightness, right? I'm not sure if I explained it correctly, but hopefully you got the point. So depending on the coverage of those samples in every pixel, you get this smoothing, like, basically. So yeah. Anyways, I probably didn't explain it good enough, but well, anyway. So this is basically the samples. Do you want to average them together or take the maximum one or the minimum one? I think probably the average one is good. So is there anything I have to fill out here for that? Image view, image layout? I don't think so. I think we're good. Now the time to know if this is correct or no. That's crazy. Well, we probably have some errors first because we have, well, actually, yeah. So add the missing fields. Oh, this is the swap chain. So just samples one, yeah. I'm not sure if I could say defaults. Probably, I would guess. And is there any other errors? Begin rendering. Expected but found mutable image. Yeah, pretty much. So here, instead of render target depth buffer, and right now we're just passing the frame really. So, and that's basically it. Begin rendering. Did we miss anything so far? Doesn't look like. But does it work? It doesn't. Why? If usage includes transient attachment bit, then bits other than color attachment and must not be set. Ooh. Where exactly? Here. But where exactly? Here. I guess it's talking about transfer source, and I'm not sure honestly why it's set to transfer source really. So let's remove that. Another error. If p depth attachment, hold on, so begin rendering info depth attachment resolve vacate image layout color attachment optimal. Oh, did I add that crap to the depth attachment or what? Vulkan spec states if p depth attachment is not null, p is not Vulkan. Yeah, I probably did that. Let me see. Hold on. Let me just run this and it would give me the line so I don't search my whole engine. Where exactly? Here. Okay. Let's see what we got. Oh yeah, I added it to the depth attachment. And apparently. Well, that sucks. I'm glad Vulkan have this cool debug tools. Otherwise this would have been crazy. So let's grab these resolves. Oops. Let's grab them up and put them here instead. What's going on? Here, I think. Well, not there. Here. Okay. Now there's one thing. Hold on. Lloyd OP. So clear and store. Yeah, that seems about right. Let's just go ahead and see. Another error. What is it now? Alright, so it said that the depth attachment has a sample count 1 bit whereas first use color attachment reference as sample count 4. Vulkan spec states image view members of depth attach they're not vague must have been created with the same sample count. Alright, I see. So I have to set basically the depth. Do I actually need to also add MSAA target for the depth though? Really? That's interesting. I guess so. But let's just try first to just change the... that's interesting. So where are we creating the depth buffer? Whoops. Render let frames. So depth buffers, here we go. New depth buffer. So apparently really I don't think so. I think we're probably gonna need, hold on, let me ask the AI and see what it says. Do I need, hold on, do I need an MSAA render target, like a separate MSAA render target for depth buffer 2? Let's see what it says. Probably, I think. Yes, you need a separate MSAA render target for the depth buffer. Oh boy. Oh boy, oh boy. This is because the depth buffer also needs to be multi-sampled to match the MSAA render target for color. This ensures that depth testing and other depth-related operations are performed correctly with the same level of multi-sampling. Yeah, apparently you do have to do that too. So, yeah. When are you gonna update the Roblox plugin? Wine Talk, welcome to the live stream. I am not sure. Like every time I open Roblox, I just can't use it, dude. I just got used to like the superior tooling in Rust and so on. That like every time I open, like I script in, like I use any scripting language, I get so frustrated. But yeah, I don't know, maybe someday or maybe not, I don't know. Like I'm not gonna update it though. I'm probably gonna make like another version of it, but yeah. But for now, I really don't have any intentions to go back to Roblox at this point. I tried recently though, but I got very frustrated. No, I didn't forget Lua. In fact, I'm pretty good at Lua. It's just that like I got used to good programming languages, like types with types and good errors, good compilers, good tooling, good IDE and so on. That like when I use Roblox and Lua, I just like get super, I don't know how to name it, but like maybe frustrated, right? I just got used to this superior tooling essentially. He's talking about a plugin that I made called the Kodachaku cutscene plugin for Roblox. So it's basically a plugin to help you create cutscenes in Roblox. So like you basically just like pick a camera position, like you navigate to whichever position you want, then you press space and then you put a camera there, right? And then you go ahead and you capture the other positions, and then the plugin generates a script for you that would like make a, you know, a cutscene with those positions. And like most people find it very useful apparently. So yeah. Though this started because like I was actually making a, what is it called? I was making a game with one of my friends, and I made a module for cutscenes, and then I thought like why not make a plugin for it? And yeah, there you go. It's actually very popular, but I didn't update it for a while. I tried to make a second, like a remake of this, but I just always get frustrated and just like give up on it. Roblox tooling is just super bad, like compared to the tooling I use now. So yeah, especially for plugins. But anyways, alrighty. Alright, so where we were. Okay, so apparently I have to create a render target for the depth buffer 2. Oh boy. Alright, so I'm just gonna copy the depth buffer here function, the depth buffer function. I'm just gonna say MSAA depth buffer, and so that would actually contain samples. Though honestly, coming to think about it, I probably shouldn't make a separate function anyways, but whatever, let's just go with it for now. I'm not sure why the IDE is flickering. Oh boy, that sucks. Okay, it's done now. Great. So let's see what we got here. So we're basically gonna set the samples here. And aspect mask depth, yeah. Usage depth stencil attachment. And here we're gonna have that transient bit too. Usage flags, transient attachment. Okay, there we go. Cool. So now what we're gonna do, let's go back to the renderer, and we're gonna need to add another render target. So MSAA depth buffer, right? So right now we have freaking 4 images instead of 2 for every frame. Do you think one day you will make your own video game? I mean, maybe. The thing is, it started for me wanting to make video games. I was very passionate about video games. But nowadays, I've got because I started young, around 13 years old or something like that. I started, of course, in Roblox. But now that I'm grown up, I don't really enjoy that video games that much. And I find them very frustrating to make. And also because of the fact that I also don't enjoy playing them a lot. And my taste in video games is very crazy. I love video games that can actually teach me something. And sandboxes and simulators, maybe some video game that would teach me how to create a computer using logic gates, or maybe some game that would teach me a bit about hacking in a superficial level, like Grey Hack, Euro Truck Simulator, Space, what is it called? There was some space game, I don't remember. Kerbal Space Program. Games like these, and these are very hard to make, and they need an actual big team. And also video games require teamwork, they require a lot of skills, not just programming. But the thing is, I don't want to deal with all that stuff, I love the technical side more, at least the grown-up version of me. The technical side more, how actually those games works and stuff. And I just want to do the programming. I don't want to care about the art, the game design, the levels, the content, basically. I don't really care. I enjoy more making the technical side of things work. So that's why I decided to try game engine programming in low level, you know, so I could actually focus on the programming side and how things actually work behind the scenes, like how the computer, you know, using just binary or whatever, you go from nothing to an actual renderer, you know, that renders 3D scenes and so on. So yeah, that's basically my backstory, I guess. So yeah. Anyways, MSAA, depth buffer. I very much enjoy these kind of questions. Anyway, like MSAA depth buffer. Okay, so we added this. What else? So let's create these MSAA. Hopefully the AI would understand already. Yeah. It understood the assignments. Perfect. Oh boy. The AI is just like very good freaking, you know, what is it called? Very good production, like productive tool, but yeah. So zip, like this would have took me way longer if I had to do this like all by hand. Like a lot of things got generated for me by the AI. Though of course a lot of times it would get everything wrong or it wouldn't go in the right direction for me. So in fact a lot of times, most of the time but yeah. That's why like if you get like AI and someone who knows what they're doing, like a good programmer, they can really replace a team of programmers because of that productivity boost. But yeah, anyways. Anyway, so what we got here, we need to zip again the image. What language do you recommend me to start with? What do you do first? What's your goal with programming? Why you want to learn it, and so on. Zip and are you passionate about this? Like, or what exactly? So what are your goal? What is your goal? That's the first question that you have to ask. So I want to make video games. I'm learning HTML. If you want to make video games, like, are you interested in the technical side or the content side? Like, are you interested on how video games work, or are you interested in actually making video games, like creating levels and so on? That's both. But like, what's more? Do you want to release a game? Do you want to release a video game? Like on Steam or whatever? Let me know. Oh yeah, I look forward to releasing one. So then I think I would probably recommend Godot Engine, honestly. Considering you have no experience, I would say probably start with Godot Engine. Really. Oh, I already work in Roblox Studio for build and GUI. Roblox Studio is fine too. I just find it quite limited. But yeah, especially if you want to make multiplayer video games, I think Roblox is quite good. Like, if you like it, if you enjoy it, then why not? It's just that I don't enjoy Roblox anymore. And the other thing is the fact that, like, when there is some game dev events, like game jams or events in my local area or something like that, I can't really use Roblox like most of the time, because it doesn't really give you an actual executable. Just like, you know, you have the game on the cloud and so on, and you can't make single player games, and you can't make shaders. But like, if you want to create multiplayer games, then Roblox is pretty good, because like it gives you a lot of things like the infrastructure for monetization. It gives you the infrastructure for advertising your game. It gives you the server, the website to host the game, all for free basically, which is great, right? And it also quite easier than to program than other game engines, though in my experience at least, Roblox video games scales poorly unless if you really know exactly what you're doing. But even then, it's kind of frustrating. Yeah. Though I do think that Roblox can really improve their engine. It's just that they're not really changing that much about it. But it does have a lot of potential. What I wanted to say. Yeah, but like I'd recommend if you're just starting out programming, HTML wouldn't help you. That's for like it's not even a programming language, first of all. And second of all, it's for web development, not game development. Game development is way different than web development. So if you just want to release a game, you don't care about how actual games work that much, then I'd recommend trying Godot. There is also Default, which uses Lua too, but I haven't tried it myself. But I see it trending currently too. So maybe you could give that a look too, though that's only for 2D. And even Godot is not that very good like in 3D anyway. But it's improving though, and it's decent for 3D like Godot engine. Default though only for 2D. It uses Lua, but it's yeah, it's actually cross-platform. Yeah, but custom configurations. So yeah, there's Default, and there is other game engine that I would actually recommend. But for beginners that doesn't know that much programming, I would go with Godot engine honestly, or Default. Though probably Godot engine maybe. If you know, like if someone is watching right now and want to start game dev and they're very good programmers, like, and they enjoy programming, then I would recommend honestly Bevy game engine if you're good with Rust. Bevy engine is really fascinating for me. It's pretty cool, though it uses WGPU. Doesn't use Vulkan directly, raw Vulkan, but it doesn't matter. Though the most amazing feature about Bevy, in my opinion, is its modularity. Like you could easily swap any or change any module. Like let's say you don't like the render, you don't like the fact that Bevy uses WGPU, then you could just like make your own Bevy render that uses Vulkan, you know, and like just swap it. And it's very attractive thing, especially for like you know, like enterprises making big products. It's like you could, like, if something is not enough for you, then you could just make it yourself and swap it basically. But yeah, and of course the ECS system, entity component system. But yeah, so if you don't know that much programming, I'd recommend Godot engine. If you know that much programming, especially Rust, then I would recommend Bevy. What else? Though Bevy is still in its early days, it's probably not very ready yet for production use. Other than that, if you like care more about to know how video games actually really work under the hood, then you would need to go through like what I'm doing right now, game engine development. So like basically here what I'm doing right now is kind of like I'm actually making the engine, not using an engine, right? But anyways, that's basically it. Hopefully that helps. Alrighty. So Okay, where we were. So zip MSAA render targets, cool. And zip MSAA. Can I actually zip this maybe then? Or yeah, fine, let's just zip this. This is getting crazy here, but anyways. Whoops. Okay, so I guess then this. Huh. Yeah, this is getting very confusing actually. You know what? Let's just freaking do a very simple loop instead of this craziness. Though I could probably make use of other tools for that. But anyways, whatever. Let's just do a regular loop honestly and call it a day. I mean, yeah, we could try to make use of other tools instead. Let's see. Well, let me make sure to go to the engine directory. Cargo add editor tools. Though the annoying thing about having a nested crate is that the IDE doesn't pick up on the change directly. So I just restart the IDE. Come on. Oh boy. Is the stream, by the way, good quality? I mean, seems alright from here. So, yeah. Render target. Alright, cool. So can I use editor tools now? Let's see. Come on. Now, if I'm correct, then there is a zip, multi-zip or something. I don't know. Huh. Where does zip come from? No, from the iterator. I'm pretty sure editor tools does have like a multi-zip or something like that. There you go, multi-zip. Oh, but it's actually just like I see. I see. So then let's say, I guess, multi-zip. And then we could say like render target. Oh yeah, there you go. So I think that's basically it. Cool, lovely. So what else now? Variable depth buffer is never used. Huh. Strange. Depth buffers never used. Okay, remove it. Alright, so what's else? What we gotta do now? We added that. Now we need to go, I think, to the rendering context and configure that maybe. So where is it? No, sorry, begin rendering in the commands file. Yeah, okay. So here. So basically we're going to do something similar. We're going to render to the MSAA depth buffer. So the MSAA depth buffer dot view. Same thing here. MSAA depth buffer, and then clear value Lloyd OP. Alaikum assalam, Woji Garen. Welcome back to the live stream. How's it going, man? Cool. What else do I need? Yeah, so right now let's add basically those resolve stuff, I think. So resolve image layout, resolve image view, and resolve, what the heck, why none? Are you kidding me? Come on. You see, the AI is very useful, but if you're not careful, but yeah, it's kind of like it basically allows you to focus more on what you want to do instead of writing the code, essentially. But whatever. Let's see if this actually works. Oh boy, error. Alrighty. Yeah, I forgot to add the layout transitions required, maybe, I think. So like, ensure image layout, red depth buffer, and let's do the same thing with the other one. MSAA render target, and depth stencil attachment. Dingo! Welcome to the live stream. Rust-based game engines don't have direct GPU drivers like C++. In Rust, much is still experimental. It could take another 2 decades for the... Not really. Not really. I'm actually using raw Vulkan binding directly. So like I'm calling into Vulkan directly here. But I know what you're talking about. You're talking about WGPU, which is an abstraction over Vulkan and OpenGL and so on. But no, I'm not using that. I'm actually using raw Vulkan in Rust here. So yeah. So this is just like C++, if not better. But you got the point. So what else? Let's see what if that error have like gone away. Hopefully it did. Not. It's not. Let's see. Alright, so color attachment, sample count must match corresponding. But why? Ah, I see. Okay, my bad, I see. So let's go to the pipeline, yeah? Where is in the rendering context? Pretty much. But yeah, the Rust ecosystem on like the game engines and the actual frameworks and so on, yeah, it's still a bit like the ecosystem for that is still not fully developed. Like Bevy, for example, it's the only, you know, popular game engine in Rust, but it's still quite early, you know, in these days. But when it comes to actual like APIs, they're just APIs, like low-level APIs like Vulkan. You could just like use it directly. That's basically the case. So here I'm actually not using any frameworks, no engine, nothing. I'm actually creating everything. Well, not everything, but yeah, you got the point. I'm not using engine or framework. I'm using the raw Vulkan binding. I want to make a game because of pedalless time versus IC. Let's not go into politics. Yeah. Alright, so what we got? Since this is false, we could just remove it, by the way. Okay, we need to add multi-sample thing here. Multi-sample state. And let's make it type 4. And it works perfect. We got MSAA. That is cool, dude. Very cool. So let's just disable validation layer, and let's go to RenderDoc and see. So remember, this is what we got before. This is the edges. Look at that, jagged, very rough. Now with MSAA, let's launch the application. Let's grab, well, actually, let's grab this capture, really. Yeah. Oh boy. Why the heck it captured all of this? Really? This is wild. Crazy. But no, why didn't, hold on. Close the capture, please. Yeah, just delete these. And let's try our lunch again. F1. Oh, I think maybe I know what happened there. I don't know. No, I don't. Why the heck it doesn't capture the actual frame I capture? What the heck? Well, whatever. Anyways. I mean, we could try again. Hold on. Let's take the primary window and let's use PRT screen instead. Okay, so that's good. But no, it didn't pick up. What is going on here? Dude. Here. Finally, oh my god. Okay, so this is the capture. Now let's go to the draw. Yeah, draw. Okay, cool. So this is the, yeah, this is the MSAA render target. Okay, so as you can see, 4x for the MSAA. And if we actually zoom in, of course, it does have jagged lines because we didn't resolve it yet. Right, so, and we have, of course, the depth buffer here, and we have a second one where we gotta resolve it, or where we actually resolve the MSAA, and there you go. No longer we no longer got jagged lines there, which is amazing. Lovely, lovely, lovely. Super smooth, dude. Look at that. So yeah, this is the, there you go. Without MSAA, with MSAA X4. But yeah, that's pretty cool. It's way smoother right now. Way smoother looking. That's cool. So what we're gonna add next? I think I should probably just give up and try to add textures and descriptor crap. Oh boy. Oh boy, oh boy. Yeah. Leak detected. Oh boy. Oh my. Let's make sure to actually like destroy the stuff that we have done, that we have made. Alright, let's go to the renderer. Let's make sure to do that, dude. Alright, cool. Let's actually do this here. Perfect. Let's make sure that got fixed now. And that's nice that it actually tells me about the leaks of the allocations that I didn't destroy. Great. Next, make armature. Oh boy. I have no clue where to even start with that. And that's very we still don't even have an actual model, you know, struct. We just have a geometry, you know, for one model. But yeah, there's just a lot of crap that we have to implement. Oh man. Anyways, all right. So I guess apparently, let's first of all actually commit this though. So let's add it first of all to the, where is it called? Yeah, to the README. Let's add it as a feature. Why not? It's not big of a deal though, but yeah. The biggest feature I think honestly in the engine is multi-window support, I guess. But yeah, not a lot of engines support multi-windows. Like, so anyways, let's actually add that. MSAA support. Honestly, I think that support name is just like redundant. Just say multi-window resolution scaling with includes. That's it. All right, so yeah. So cargo trauma, what we have added here? Yeah, edit tools, I see. Is there any warnings that we want to fix? Let's just commit this first. Add MSAA. Commit. Let's push this. And let's go to the next one. Yeah, I think I'm just gonna go with trying to implement the descriptor indexing crap. Oh man, I have been procrastinating for forever. So let's see. Oh man, Vulkan Bindless textures. Da da da. So which features it needs? It needs runtime descriptor array and descriptor binding partially bound. Apparently. But what about descriptor indexing? I don't think these, no, that's probably not the right one, I think. I don't know. Let's see this one. What it does do. I mean, yeah, it is descriptor indexing features, yeah. See you later. Goodbye, Woji Gearing. Thank you for coming in. Da da da. So we have shader sampled image array non-uniform indexing, which updates after bind, array non-uniform indexing, binding uniform buffer updates after bind. Oh boy. Crazy stuff. Crazy. But honestly, buffers, I don't need them. Like, I don't need bindings for them. It's like I already use device buffer address, which is fine for me. I only need textures. Create bindless descriptor set layout. Uniform buffer, storage buffer. So how this is different from the other one that we've seen earlier? Da da da. Okay, what about just saying Vulkan bindless? So this is the first one that pops up, and then there is this PDF right here. This one I guess uses HLSL, right? Yeah. Buffers, no need. Images, yeah. And this is actually in yeah, this presentation is actually by the same people that made the GPU allocator we're using. And this is actually in Rust. Though I did try to see that presentation, but it was super confusing, at least for me. Probably just a skill issue. But it's wild. Descriptor pool sizes. I wonder if there's any Ash libraries, honestly. I don't think. There isn't that much. Oh boy, my tutorials. Ash. I mean, we could do something maybe interesting, which is possibly go here, then go to crates, IO. Go to the dependents. So the one, like the crates that are actually using Ash, like, and it actually gives us from the most popular. So the most popular one is, well, not most popular, but like the most doloids basically is WGPU-Hall, so hardware abstraction layer. GPU allocator, this is the one that we're using. Great. Vulkan API backend for GVXRS. This one is deprecated. GFW. Okay. Volcano. Yeah. Ash window. Slint render Skia. Skia is like render made by Google, basically. Beryllium. Opinionated wrapper for Fermium. What the heck is that? High level. Mostly safe OpenXR bindings. GPU alloc Ash. Ash backend for GPU alloc. Ash Molten, statically linked Molten VK for Vulkan on Mac using Ash. VKMem, this is a binding for Vulkan Memory Allocator VMA, but it doesn't work anymore. It's not, you know, like, it's not maintained. What else? Rafx API. Rendering framework, lib shader, C API, Rafx, yeah, Vulkan render for MGY, is the L2 wrapper, tray to host Ash with Winit. Ooh. Fidelity FX Super Resolution 2 bindings for us. What is that? Another live coding tool for creating shader demos. Okay, fast powerful Vulkan abstraction library. I don't think, but let's see. Bilka, Homebrew probably. Rust library for shaping, placing, and rasterizing text primarily for Basalt. Huh. Small but powerful graphics library. RAII helpers for Ash. A lot of these are probably just not maintained anymore. Yeah, GFW pass-through, app service. Integrate WGPU into your existing VK sync. Let's see that one too, why not? For writing simpler Vulkan code. Just pipeline barriers, forked off, Ash, shader, creator. Huh. EGY when it's Ash integration. Okay. So yeah, I think that's enough for now. We reached the 5,000 doloids. Let's see, where were these? About 2 years ago. So this is, no. FSR, 7 months ago. Nice. Over 1 year ago. Probably no. Ash, Pan, no. 5 years, oh boy, no. 2 years, no. 3 years, no. Can I see the GitHub repo here? Last year, no. So yeah, like from this whole thing, that's probably the only one that is lightweight Vulkan wrapper. Graphics abstraction for blades, surfable. This one is 10 months ago, and this one is 2 years now. Board is an ambitious, lightweight Vulkan wrapper on top of hash. Probably in May. Well, actually 3 months ago, so. But too late, we already made our own abstraction, so. Anyway, so this one, FSR, by Embark Studios. Okay, that's interesting. I'm not even sure what this is about. And save Rust bindings for Fidelity FX Super Resolution 2. By the way, I'm interested into using Vulkan video extension later on to capture, but it probably would be insanely hard to implement. But we'll see until then. So what is this? What is an open source high quality solution for producing high resolution frames from lower resolution inputs? Huh. But how that exactly works is a cutting edge upscaling technique developed from the ground up to produce high resolution frames from lower resolution inputs. I mean, we kind of have an upscaling thing, right? But our upscaling thing is just like blitzing the image, you know. It's essentially a C++ wrapper, and much of the development remains private. I believe most of the components are still not openly available. Huh. I mean, it says open source, and there is an actual Rust binding for it, though a raw binding, just like Ash. So Fidelity FX, output buffer, R16. Current frame render resolution. So like basically what this is, at least from what I understood, is that you remember when I had like low SSAA, you know, like 0.1, where we had like a big pixels. So it's kind of like if we had that and we pass it through Fidelity FX, it could probably produce much nicer results even though it's low resolution. But yeah, I guess we could look into it later on, but that's interesting. Anyways, let's just go back to our actual thing, which is Bindless right now. Nice thing about this one, it's actually made in Rust. So that's cool. Now I just need to see which tutorial I should go with, because each one is actually different from the other. They're doing different things. Not too different, but different things. I guess maybe let's go with this one, give it a try. I mean, it's vulkan.org, so oh boy. But I do remember it's not very simple. Anyways, let's just see. Setting a goal. So we have create a bindless system that can be used between graphics APIs, write API agnostic shaders that support bindless resources, load in resource type. The other problem with this one is using HLSL, and I'd love to use HLSL, but I have no clue how to make use of it right now. So Overcome the existing limitation with HLSL. Okay. Can be as the following types: buffers, minimum 4 sets. So the Vulkan 1.2 spec guarantees a minimum of 4 sets. We made the decision to use immutable samplers for the time being to minimum spec for certain devices. VKEXT mutable descriptor type, VKEXT descriptor buffer. Anyways, bindless table type to vk. If it's a buffer, storage buffer, texture, retrieving descriptor pool sizes. The Vulkan descriptor pool requires a predetermined amount of descriptors per resource type. Descriptor count is set to an upper bound. We simply use 100,000 here. Oh boy, immutable samplers are treated separately and are set to the user-defined maximum amount of samplers. So, descriptor pool sizes. Honestly, I find this hard to read, but I think essentially we need to create a descriptor pool right now, right? So let's just try to do that, honestly. But it didn't say which extensions it's gonna be using, dude. Well, let's say it later. Huh. No, I didn't. Honestly, I think this would probably not great for me. Maybe a skill issue, but let's just maybe go with this one anyway. Alright, so first of all, what we need here is vk device features 2 from the physical device. Non-uniform indexing updates after binding flags for textures, uniforms and buffers required for our extension. So this is the stuff that we're gonna need in the descriptor indexing features. And the descriptor indexing features is this: vk physical device descriptor indexing features. Alright, let's see. So we're gonna go to the rendering context for this one. So, Alright. Let's see. We're not gonna check for that stuff now. Let's go straight to the where should we add this? I think the hold on. Maybe here. Probably here. So let's push next and mutable vk descriptor. What is it called? Physical device descriptor indexing. Features. Default. So this is what the AI actually suggested. Shader input attachment array dynamic indexing. Uniform textile. Nah, let's not deal with the AI right now. Let's just in fact, I can just copy these and maybe the AI would understand what it needs to do here. So just comment this out and let's see. Well, actually I wanted to put it here, dude. Boom. Let's see if it's understood the assignment or not. You probably did. Yeah, I did. That's cool. Alright. No need for crazy Vim techniques, just AI. So, anyways. Yeah. It's just a skill issue on my side, but well. Alright, so that's the features that we need here. What else? Create bindless descriptor, set layout. Well, let's see first of all if everything went well with actually enabling these. Yeah, no error. Though, do I have the validation on? No, I don't. Let's make sure to do that, dude. Oh boy, we do. Alrighty. If the PNX chain includes a vacay physical device Vulkan 1.2 feature structure, then it must not include. Huh. So I guess maybe I can just add all those features in that structure instead. Probably, yeah. So let's just remove these, I think, and then go to 1.2 features and add them here. Though I'm not sure why it didn't include descriptor indexing like the tutorial. I don't know. Crazy stuff. Oh boy. What's wrong? I'm not sure what the heck is wrong with this. Oh, I see. Alright. Alright, good. Let's try now. Perfect. So the first step is done. Enabling the features we need. Now that you, well, by the way, I will remove some features that have to do with the buffers, because we already have buffer device headers, so we don't mind about that. So like shader uniform buffer array, we don't care. Buffer updates after bind, we don't care. Buffer array, we don't care either. Binding storage buffer update, probably we don't care. So the only one that are left are shader sampled image array non-uniform indexing and descriptor binding sampled image updates after bind. So like basically for the images. Though isn't that the same thing that we've seen in Bindless texturing here or somewhere like that? Well, Bindless textures. Here, I think. No, this one actually enables some other things, apparently. I'm not sure why my mouse suddenly is faster, but... Oh boy, this is very confusing. But to be honest with you, I'm probably gonna go with this one, you know, because I only require images. I feel like. Descriptor binding partially bound. But why they're using multiple features? I mean, it's the same thing, dude, I guess. And my mouse broke. That sucks. Okay. Right, shader sampled image array. I'm not sure what the heck is wrong with my mouse now. Oh boy. Okay. Ah, shit. Why the heck everything is slowed down? Crazy. You know what? Let's just go with the first tutorial and continue with that, honestly. I don't care. Let's go with the first tutorial. And just keep everything there. Okay, cool. Let's just continue with the first one. Yeah, fine. Alright, so create bindless descriptor set layout. Now that we have enabled descriptor indexing, we can create our descriptor set layout. Bindings that are partially bound can be updated after binding. Okay, cool. So what we're creating a descriptor set layout. Okay, cool. Let's go ahead and do that. Righty. Now the real question is when we're gonna do that. Ba-ba-bum. So we created a device. Yeah, I think let's do it in where we're creating the allocator. I think in the window renderer, right? Huh. Yeah, let's do it here. Let's do it here. So before the let's do it with the command pool. Alright. So descriptor set layout. Only one descriptor set layout, correct or no? Vacate create descriptor set layout. Yeah, only one. And this should be default. Default. Remove the build. Alright, for this one it basically said it gave it like 2 bindings, I think. Uniform buffer and combined image sampler. Okay, so what happened here exactly? We have 3 bindings apparently. One for uniform buffer, the other for storage buffer, and the other for combined image sampler. I only need combined image sampler, so we could remove this crap right here. And what else? Descriptor count, it's set it to 1000 due to partially bound bit. This value is used as an upper bound, which we have set to 1000 to keep it simple for the sake of this post. Okay, let's set it to 1000, why not? And for the sage flask, stage all, okay. Alright. And the flags, partially bound and descriptor. Alright, cool. Probably not here, I would guess. Here, I think. Yeah, flags. Huh. Where is that exactly? No, it's actually in the binding, dude. Layout binding. But why it didn't actually... No, it doesn't have it. What? Am I tripping? Okay, where it's using that flags? Oh, here, binding flags. Now, where is that being used? Oh, in the pnext of the create info, apparently. I see. That's why I kind of hate this way of doing things. Like if I was using C, I would use, I'm not even sure what's that called. But basically everything is in one struct instead of like every time you have to look up, you know, do a lookup like a pointer, you know. But anyways, it's very confusing, whichever. So pnext, let's actually do that. So push next, I think, or in the create info. Push next. Exactly, perfect. So partially bound, and what else? Updates after bind. I'm not sure though why, like, oh, I think that's strange. I probably am supposed to do it though like this, dude. Yeah. Updates after bind. What else? Anything else? Select. Do I have to set a binding count here too? Apparently. Actually, what? Oh, it would be set by the binding flags, I see. Cool. And yeah, I think that's probably it. Now let's actually do this and see if it works. Oh no, we have an error. So p binding flags includes descriptor binding updates after bind bit. But vacate descriptor set layout create flags is 0. If any binding has the binding updates after bind bit, set flags must include. Ah, I see. So let's go to here, I think, and then dot flags. Yeah, I think that's the one. And we have another error. So descriptor binding partially bound is not enabled. Huh? But like, why then the tutorial didn't include it if it's not there? It doesn't exist, right? Yeah. Weird. weird, but let's include it. Alright, so the tutorial apparently was missing this one for some reason. That's a red flag, but anyways, we'll just continue with this. Now we have to create a descriptor pool, right? Or, well, actually it's the one, no, descriptor layout. Yeah, let's create a descriptor pool now. So max sets 1000. Pool sizes, combined image sampler, descriptor count, and we need flags. Perfect. Now create a Bindless descriptor set. Let's make sure this works. Perfect. Let's go to the next step, which is creating a descriptor set. So the descriptor pool is that, and the set layout is that, which is correct. I think, well, hold on, let's see. Yeah, it is. So now let's actually allocate some descriptor. Well, actually we've done it, yeah. Allocate, yeah, cool, lovely. So that's basically the setup, apparently. That's cool. Now we have to actually, so these are the descriptor set, this is the descriptor pool, and the descriptor set layout. Like, man, I just want to freaking pass textures to a shader. Like, why the heck I have to go through all this crap? It's probably because of compatibility crap, so that's why we're making use of Bindless here, but yeah. Anyways, how are we gonna do this? Now the thing about Bindless is that we're gonna have to deal with this stupid descriptor set layouts and stuff like this just once. At least that's what I hope so. So yeah, because it just doesn't make any freaking sense to me. And yeah, window render. It's just like the render path, just overcomplicating crap for no reason. Anyways. So where I'm gonna put this now, let's put it wherever, I don't care. Let's say, so the first thing is the descriptor set layout, right? Yeah. So descriptor set, no. Come on, there you go. Descriptor pool, perfect. Descriptor sets, that's it. Now let's actually go ahead here and put them inside of the fields. Now we're done with the freaking setup, I think. Now what? Now we need a way to write all our resources to this global descriptor set and a way to pass these resources to our pipelines. Render handles. We can write data to any arbitrary index of a descriptor set. This index is typically of type UN32, which is aligned with GLSL. But then when we are going to create two handle types, buffers, and text and scope, then observe compile time checks. Huh? What? Updates Bindless descriptors. For the sake of simplicity, let's assume that image view, and buffers are already created. Let's create two methods that stores the resource in an array and return us two handles that we can use in our descriptor. Huh? So we got descriptor set, really textures, So store textures, or store texture, aka image view, and you pass it a sampler. Then I push back the image view into the textures. Then image layout, shader read only optimal, image view, sampler, aka image info, aka descriptor set right, image sampler, texture binding, vk update descriptor sets. Well, let's start by actually creating some textures. So I got that mesh that I used for 3D from this tutorial. So in Lloydin models, right? So let me grab the Viking room PNG too. Let's try to actually load that into memory first of all. So save the image as vikingroom.png. Let's put it into desktop real quick, and let's see. So res here, let's actually put that thing in here. Okay, and let's add it. I don't know why my mouse suddenly just changed sensitivity. It sucks. Anyways, let's add this guy. And now we're gonna need the image crate to load that. Oh boy, I gotta add it to the engine instead. So cd engine cargo add image. Right. So now I added that, perfect. So let's load the image into memory. Where are we gonna even start with that? Now, we're gonna have in the future, of course, this wouldn't be hard coded into the renderer. We would have like a scene thing, you know, a scene struct or a scene object, and like the renderer would determine how to draw that scene dynamically, right? But currently, you know, we're just, you know, hard coding everything into the renderer basically. But anyways, let's just say let textures where I'm gonna put exactly, let's do it in the renderer, fine. Swap chain images, well, no. Well, actually, maybe we have to make our own structure already. I don't care, dude, come on. So create image. So basically Lloyd res slash vikingroom.png. So image create Lloyd, is that it? Come on, using the Lloyd, using the image crate. Okay, let's see. Oh yeah. No, not engine image, dude. This is super annoying. Let me just restart my IDE. Because the thing is, I already have a module called image, basically. So that sucks. Let's wait. Oh boy, that's taking years. All right, are you? No. Okay, hold on. How can I access the image create instead the image module? It didn't understand what I mean. But I think to go from the root, maybe like this. Does that work? Yeah, perfect. And then maybe like this. No, it's not. Huh. You know what? Let's go to the image documentation. I don't care. AI is very useless here for some reason. Rust image. Image reader open. Okay, cool. There you go. This time the AI failed horribly, but anyways. Alright, so we got an image now. So what's next? Good question. Image data. So into RGBA8. Consume the image and returns an RGBA image. It is returned as is, otherwise a copy is created. I see. Okay, fine. Now what's next? We're gonna need to create an image, create GPU image. So yeah. We're gonna need the allocator. True. Where's the allocator, dude? I think I've... Where did I create our allocator? I think in the renderer? Yeah, probably. So... Okay, let's go ahead and do that. But I didn't... I created renderer afterwards. Alright. So where's the allocator or the renderer? Here. So mutable renderer allocator. Make renderer mutable, please. Now the name, apparently. I don't care. And now I think the image attribute is correct. So add the missing fields. Don't know why the AI sucks now. Let's import this guy. Allocation scheme import. And known, no. GPU only. GPU allocator managed. Oh boy. 1.0, let's say RGBA ATU norm. Yeah, that's good. Extend. Well, the image dot width, I guess, as U32, right? Or what? Value used after being moved. Oh boy. Can I bring that thing over here, please? Cool. I see. So let's call this, I guess, GPU image. And I guess maybe into RGBA actually consumed it. Ah, I see. Damn. Alright. Well, actually, let's say let image is equal to that first. And then let image data. Or just keep it like that. And let's just, now we could actually make use of image.height here, image.width. The samples 1 here, none of that. Probably only sampled and probably shader read maybe or something like that, or isn't it? No, maybe not here. No clue. Let's keep just sampled, I think. Linear false, of course. I don't think this would cut it. There we go. Color, base map level. Yeah, that's great. Perfect. Well, actually, let's use the builder instead. Just to stay consistent. Perfect. So yeah, we created GPU image. Now we actually gotta use some staging buffer here. So we're basically gonna put the data into our staging buffer. Oh well, where's our staging built? Well, it's definitely not here. It's inside of the render. Oh boy. Actually, it does make sense to make this crap into the renderer, yeah. I created the command pool here because we needed it here, I think. Yeah, probably. Yeah, let's actually move this stuff from here, please. Let's take these and let's put them somewhere around here. Let's take all of these now and remove them from here. Remove this stuff from here. I didn't copy maybe the descriptor set layout or what? I don't know. Let's just do this. Now let's go here. Here. Let's remove this stuff. Did I take the layout with me? No, I didn't. Okay. That sucks. Let's take all of this stuff now. And let's go to the render, please. Let's put that there. So we're gonna need this staging belt right here. So let's just, I guess, maybe. Oh, by the way, camera buffer.write.done, please. Come on. No? Huh. What? How? Oh, this is just the buffer, my bad. I see. Not the staging belt. I see. Well, let's actually put this stuff before the staging belt, yeah. Yeah, let's put them here. This should be into its own function, but right now... Probably actually in the image module, but anyways. image, and then image, GPU image, and now the staging belt. And so what we're gonna basically do is write the image data, write image as raw, then copy to GPU image. Oh, expected buffer found image. Yeah, okay. We need a new function there apparently. So let's go to our staging belt here. Let's add a new image. Commands copy buffer to image. Well, I gotta add a new command now. That's interesting. I don't think I need the layout there. And could probably just say this. Right. Import engine image. Copy buffer to image. Now we gotta add a new command. So where's the copy buffer command here? There you go. Let's put popfn copy buffer to image. Perfect. Let's see if it's correct. Expected mutable image. Sure. We need that mutable because we're like changing or mutating the state of the layout state thing. Like the thing that tracks the layout basically. So you gotta make sure that destination image is transfer destination. Oh, by the way, I actually haven't done this here. But what the heck is wrong? Oh, mutable. Probably. Actually, do we? I don't think we have. my bad, sorry. That's for the image layout stuff, not the buffers. Yeah, I'm stupid. Anyways, what's going on now? Alright, so buffer offset, buffer row length. Okay, so there's some crazy stuff going on here apparently. So we make sure that the image layout is in transfer destination. Good. Then we copy buffer to image. We give it the source buffer handle, destination image handle, destination image layout, and then regions. VK, CMD, buffer offset. Well, we do need the offset, I think. Right? Yeah, so like the offset is in the SRC offset. Yeah, so we need the SRC offset, please. So U size, or well, VK device size actually. So yeah, let's see where we're gonna add that in the buffer offset probably. And buffer row length, buffer image height. Huh. Can I see the documentation of this, please? So buffer offset is the offset in bytes from the start of the buffer object where the image data is copied from to. A subregion of a larger 2 or 3 dimensional image in buffer memory control the addressing calculation to be tightly packed according to image extent. Alright, so I could set them to 0. I think. I mean, we'll see. Image separate source, image offset. Yeah, the default values there. And the image extent. Yeah, I think that should be okay, yeah. So, where we were. So does this work now? So copy buffer to image. Image and copy cursor, yeah, correct. So this should be mutable, of course. And there we go. Now, of course, copy cursor, we gotta advance that. And apparently we have no image attribute size. Well, that's a good question. What is the actual size of the buffer? Oh boy. Well, I would guess the width times. Well, maybe we could take the allocation size. No? Oh man. I mean, we do have the extension, we have the format. Maybe we could get the allocations. No, that's gonna suck because it could be sharing an allocation with the others. So yeah, what we're gonna do for now, I think. Boy, that is crazy. Yeah, let's just use the extent to calculate that, honestly. So image attributes dot extents dot width times height and times, for now we're just gonna hard code it to 4, I think. Yeah. I'm not sure if there is a better way to do this. Probably not. But for now, we're just hard coding that. As vacate, well, as usize probably. Right? Or what? Oh. Is that it? Yeah, probably. Now self. Okay, that's good. I think that may work. Let's try it. So where we're actually making use of this. Copy to, copy image to. That's the staging belt. Okay. Make mutable. And of course I gotta account for its size in the staging belt. Dot len. What? I don't think that's what I want. I don't know. So let me just make sure to say as raw.len. Or what is as raw? Hold on. Raw buffer. But I think it would be this, the pixel, right? The container. I think so, yeah. So I guess maybe length times 4 as vacate device size. Or maybe first as. Or image.components. I'm not sure if there's a better way. But anyways. Hopefully I didn't screw this up. Cannot find value render in the scope. Yeah. Now I gotta actually store these. All this crap. So, oh boy, that's a lot of stuff right there. So descriptor, set layout, pool, descriptor sets, GPU image. I'll actually gonna say textures, really, which is gonna be a Vic image. I think that's maybe it. Yeah, I think so. Ah, boy. Let textures is equal to Vec GPU image. I'm gonna actually rename this to texture, because that's exactly what a GPU image is. Add the missing fields, and there we go. Now let's see if this so far works. I don't think so, but we'll see. Like, I don't think so it would work from the first try. There's just a lot of things that could go wrong here. If it does, then I'm lucky. Oh yeah, I knew it. So what is the problem? Image transfer DST of optimal is not compatible. With Wiki image usage flags. Sample bit. Oh yeah, my bad. So we do need that transfer DST. I see. So where are we gonna do that again? Render, and where we're putting the usage flags. Let's see. So here, yeah. Sample transfer DST, and hopefully that's all we need. And oh, it actually worked. That's interesting. I mean, at least no errors. If it really worked, I don't know. Good, now we actually have a vector of textures. Perfect. What's next? So now we basically, I guess, gotta use Vacate update descriptor sets somehow. All right. So let's do that. So self.context, or well, context.device. Do I need to do that for all textures or what? I mean, I guess so. Whoops. For texture in textures. iter, no. Say, let's see, self, well, context dot device dot update descriptor set. Alrighty. So destination set, descriptor set 0, destination binding 0. What? Texture binding is equal to 2. I see. And destination says that descriptor type combined image sampler, image infos, image view, image layout. Okay. Now this actually should be in the commands, right? I mean, well, is that a command? No, it's not. Alright. Well, we gotta indeed transition the images, yeah. But hold on, we need commands for that. Do we even have commands? We do, yeah. So that's great. Commands dot transition image layout to shader read only optimal. But the AI effed up here again. Mutable texture, is it? Well, iter mute here. No? Well, this should be mutable, yeah. No. Oops. Now. Well, come on, dude. Image layout state. Transition image layout. We gotta need a new state. Okay, so it's not imported. What in the world is happening here? Come on. Okay. Shader read only optimal. So basically, let's go to the image layout state here. Why the heck? I don't understand this, dude. Like, come on, that sucks. Anyways, let's go to here where the image, there you go. And let's go to the layouts, there we go. And let's add a new one. BobFN, or maybe we could call it texture, no? Nah, actually just say shader read, why not? So access shader read, layout shader read only optimal, and stage fragment shader. Fragment shader, huh? I guess so, yeah, pretty much. And we're also gonna need soon shader write too. And why the heck it's saying layout general there? That's interesting. Huh. I mean, is there no shader write only or something? That's strange. Or maybe probably, I don't know. Anyways, no need for this now. Okay, cool. Now let's go back to the renderer here, I think. Yeah. Now we could hopefully use our new thing. Shader read. Alright, good. Perfect. And then we need to update the descriptor sets. I'm not sure if I can only do that after I complete the transition, because if that's the case, Oh boy. I have to wait until render time maybe or something. We'll see. Anyways, what's going on? This two simpler, sure. The descriptor is compiled. Pass draw parameters. So let's see if this works without any errors. I think this would probably make an error because there is no transition yet. Like the commands aren't submitted yet at this point. Attempted write update to sampler descriptor with invalid sample. Oh, we do need a sampler. Yeah, I forgot about that one. So, can I just make one on the fly here and reuse it or something? Let texture sampler, I guess. Why the heck you have all that crap? Image view sampler equals sampler. Well, yeah, the textures could have different samplers, but let's just use one and reuse it for now. Compare, enable, false, blah blah, whatever. And here where we're supposed to actually do this, sampler, where is it? Image view, image info. Here we go. So sampler, texture sampler. Okay, cool. Is that it? Let's see if there's any other errors. I see. We don't want that crap now. And it's anisotropy. I mean, this is 0 anyways. Honestly, don't set any of this crap. Just, it would tell me what I need to set. Let's just go to the default values. Alright, so that seems to work with no errors, which is amazing. Great. Now pass draw parameters to pipelines. There are two ways to access resources from Bindless descriptors. Accessing resources from other resources. For example, material data stores index to a texture. Then the shader finds a texture based on index stored in material. Accessing resources from draw parameter. For example, figuring out where the camera buffer is. In this post, we are mainly going to focus on two and provide draw parameters to the pipelines by binding a dynamic uniform buffer with dynamic offset. There are two reasons why we'll use dynamic uniform buffers. We only need one descriptor and one buffer that manages all the data for all the passes. The indices stored in the uniform buffer will never change. Constants can change. The entire line buffer can be updated. But the index will always be the same. So we'll never update this descriptor after initial setup. Dynamic uniform padding alignment. What the heck is this crap? I have like one quirk. Dynamic uniform buffer descriptor. Each range of data in the buffer must be padded to fit within the minimum. I don't think I'm gonna need any of this, hopefully. Specify ranges during initialization. Come on, just tell me how the heck am I supposed to access this stuff now? PBR params, mesh transforms, point lights, camera skybox. Build the uniform buffer in descriptor. Bind our bindless descriptor set once for all passes. Alright, so vkcmd bind descriptor sets. Alright, let's go ahead and do that. So we're gonna do that in the render function, I think. Well, the draw function. So after the bind pipeline, let's bind. Well, we don't have a command for that yet. Let's add it. Pubfn bind descriptor set. So cmd bind descriptor sets. So graphics currently, though I would need compute later on. So, but for now, no need. Pipeline layout. Okay, and first set 0, descriptor sets, dynamic offsets. I mean, that should probably work just fine. And yeah, okay. And let's go back to our render now and bind descriptor sets. So we don't need this for now. Self.pipeline layout, descriptor sets. So we don't need this scene too. Come on, dude. And there you go. Perfect. Now I think we bound the descriptor sets. What's next? Oh, bind descriptor sets again? Why? Ranges. Oh, maybe it's talking about that. I don't know. Though since I bound the descriptor set right now, I think I could try to access now that in RenderDoc and see if we have a texture there maybe. And let's try. But hold on, is this working fine with no errors? No, there is an error. So what is that error? vkcmd bind descriptor sets. Being bound is not compatible with overlapping descriptor set layout and index 0 of vk pipeline due to only contains zeros. Oh, right. So I have to update my pipeline layout. Alright. So now the real question is, where's my pipeline layout? Here it is. So we only have push constant ranges. Now we need to add set layouts. All this crazy setup is super annoying, honestly. It makes zero sense. Anyways, no field. Well, I'm gonna need the disk. Well, hold on. Can I actually make these afterwards? I think it's like, yeah, I think probably we can. So after the descriptor set layout, please, we could, I guess, make the pipeline layout and then the pipeline. Perfect. And now we added that. Okay, is that it? I mean, there is no errors. So can we try to run that in RenderDoc now? And see if we can access the textures to just... So primary window, PRT screen, close. And let's see what we got. So vacay draw, and we have, let's see, pipeline maybe, descriptor sets, how can I actually... I don't think so, apparently. So let's just see how we can actually put that into a shader. Oh man. I have no clue what the heck he's doing here. He's using some dynamic offset crap just for buffers in shaders. So add non-uniform qualifier extension here. So we do not add it for all our shaders that use Bindless resources. Huh? Define Bindless one. Always bind the Bindless descriptor set to set 0. Oh man, it's like he's using the things, the macros directly. Just show me how it works first. Anyway, register empty resources to be combined with the pipeline launch. Register textures. Here's an example generated code. What? Oh boy, I have no clue what this is talking about. Where is the images though? It's only talking about the... It's only talking about buffers, I think, here, no? Oh boy. Maybe we're gonna need, I mean, let's just try something. That is crazy. Let's see the other tutorials, what they do in the shader. Okay, they do it like this. Oh my god, thank you. I can't believe that tutorial doesn't have a single line like that. Alright, so let's try this one. I'm not sure if that's one that's gonna work, but let's just try it and see what's gonna happen. So layout set equals 0. And I mean, I would guess binding 0. Uniform sampler 2D textures, I think. Now the real question is, would that work? I mean, does it even compile? Yes, it does. Now the real question is, does this actually work? No clue. Well, first of all, we need the UV from the object. So to add that, it's very simple with buffer device address. I'm just gonna go to geometry here. Let's add UV. Okay. Now we gotta actually edit our code here to do the thing. Perfect. That's probably how it is supposed to work, I guess. And they're called text cores. Cool. So, and then we basically change the push constants here. Add a vec2 here, UV, or text core, if you'd like. Yeah, we could call it that, why not? It doesn't matter the name, but anyways. Though you have to make sure it's the same here. And perfect. Now let's actually try to make use of that freaking texture. So. Let's see how it's gonna do it. So text color is equal texture, and it's accessing the first texture. Vec2 frag position.x. Not really. Or is it? Well, I mean, you have to get the UV though first. Hold on. Get UV from vertex. Well, actually, I need to do in the vertex shader. Sorry. So I basically need frag normal, then layout, location to input vec2, and we're gonna have frag text chord, too simply, yeah. And let's actually copy this guy. Let's go to the shader vert. Let's do the same thing here, but output frag text chord. Alright, and then afterwards we're just gonna say frag text chord is equal to vertex.text chord. Let me just make sure that it is the actual name here. Yeah, it is. Perfect. Now let's go back to here, and now we could hopefully make use of that. So, well, shader.frag now, and let's get texture color. So frag text scored, perfect. And now the moment of truth. Let's actually try it. Well. Let's just let the AI regenerate this thing. There you go. Now let's see if this actually works by any chance. Hopefully it does. It does. But is that really correct texturing? I don't think so, or is it? I mean, yeah, the texture is there, I guess. So, but that texture looks very strange, honestly. But yeah, it works. Perfect. Lovely. So we got texturing, apparently. That's cool. Love that. Love that. Can we go to RenderDoc, make sure everything is correct? Layers controlled by... Oh, I don't have the validation on. There could be some problem there, like, hold on. Let me make sure there's no validation problems. Come on. Okay, there's no validation problems. Amazing, lovely. Now let's actually disable them and go to RenderDoc. And make sure everything is fancy dandy, so no primary window, print screen, and let's open up the frame. Let's see the inputs here, draw indexed, and look at that. So the texture is loaded correctly. Perfect. And that's the output right here. Look at that. So yeah, we actually added textures apparently, which is very cool. All right, let's actually commit this, but I mean, we probably want to make this extendable. But let's just commit this stuff first, actually. Add textures. Commit and push. Oh, all right, fine. Shift F6, text core. Oopsies, text core like this. All right, commit and push, please. Now, push. And we're good to go. Nice. The next feature that I wanna implement is tone mapping. Tone mapping, because we already have a high dynamic range, render target, but we're not doing any tone mapping. So like, it's just, I think maybe a linear copy or whatever, I don't know, discrete one, I don't know, but we need some tone mapping. And we're gonna do that using a compute shader, I think. Oh boy. I don't know if I can make this work like everything I've done so far, but I guess we'll just try it. Is the stream still fine, by the way? No dropped frames, perfect. Alright, let's see. Where do we even start? Let's go, I think, to the rendering context. And then what? So create graphics pipeline. Now we want to create a compute pipeline, basically. Oh boy. Let's see if the AI would do a good job here. So it needs a compute shader module, yeah, pipeline layout, and a pipeline cache. Perfect. Entry point main, perfect. Create compute pipelines, pipeline cache, default, compute module, name, entry, blah blah. Now let's create a shader for tone mapping. So new tone mapping dot comp. So add, and let's see. So of course version 460 tone mapping shader. Right. Input image, output image, then this. Okay. But the thing is, we cannot really, we're not using these kind of things. So how are we gonna do this? Good question. I don't know. Shader frag. So this is how we've done this one. Let's compare it and see what's the difference there. So somehow it didn't have to add these formats. I don't know why that's the case. And we actually said sampler 2D instead of image 2D. Huh. That is crazy. I don't think I could make this work. Right. I mean, we have our first texture on this first slot, and hopefully we could put the other ones in the second and the third, maybe. So like, here's my guess. My guess is that we could just say, so the input image, well, what it's supposed to be, well, it wants a sampler 2D. Can we actually get an image 2D instead? Oh boy. Let's just say image 2D, input image. Well, we already using the first slot, so maybe we could hopefully use the second, the third somehow. Does that actually even make any freaking sense? Nah, I don't think so. I don't think so. Let's actually see how we're like setting that up. Hold on. So where did I put that? Probably render, yeah. Update descriptors, or so we're going through all the texture and we're saying update descriptor set, destination set, combined image sampler, image info. Texture. Oh, what the heck? But like, how do you actually, how do you give it the index? Is it binding? I mean, I would guess so. Like, I mean, yeah, if I just run this now, okay. Well, apparently it doesn't like what I've done here. So we probably need maybe the other extension that we've just added, maybe. I didn't add any extension, what? That is wild. So what it's talking about then? Image 2D type can only be used in uniform variables or function parameters. Alrighty, interesting. Well, you know what? I don't care. Let's just do whatever it takes. It doesn't have to be the same setup. So I don't care. Let's go ahead and say uniform image 2D, input image, and then output image, binding 0, binding 1. And we'll figure out how to do it, I guess. I don't know. And so does this actually work? Image variables not declared write only. And without a format qualifier. Not support for this version or the enabled extensions. Oh yeah, I see. Perfect. So now, can we compile? So the compute shader right now got compiled. Perfect. Now let me just try something interesting here real quick, just to try something. So window render or render, probably render. Destination binding. So what if I said 1? I think it would break it, right? But then what's the point of all this setup? Crazy. What? Even though I changed that, it's still... I'm super freaking confused now. Oh, there is an error. No clue, what the heck. Whatever, I don't care, whatever. I genuinely don't understand. Actually, let's go back to the tutorial and see exactly how they're doing it. Yeah, this is very freaking confusing. So store texture, but what about store textures? Nah, this tutorial is... It's either a skill issue from my side or this tutorial sucks. I don't know. Maybe I should have probably gone with Bindless texturing instead. Here. Yeah, probably. You also have way less features and such. But yeah, honestly, I don't think it's a, yeah, let's just, I don't know. I mean, I guess let's just go on and see what would happen, pretty much. Yeah, fine, whatever. As long as it works, good. So, okay, cool. Where we're creating the pipeline again, let's create our, do we have to do another pipeline layout for that thing? I would guess so. Yeah, let's just start fresh, honestly. Tone mapping. So Vkeeper constant range, blah blah. Let's try to reuse the same thing and see what's gonna happen. Maybe. Oh boy. Yeah, honestly, let's leave this for the next stream, really, off camera, really, because this is gonna suck so bad. Yeah, let's leave it to the next stream, pretty much. So, is there anything else we could implement now? I don't have anything in mind. So yeah, I guess it's probably gonna end the stream here then. Pretty much, really. To the next stream. So, yeah. Yeah, we have done it. We got a model with a texture. Crazy. Maybe we could try to implement shadow mapping. I don't think that's easy at all. So we can have shadows. But yeah, I guess that was it for this stream. Thank you all for coming. Thank you for Loop Luminary, One Talk, and Woji Gearing and Dingo. Thank you all for tuning in. And see you later. Goodbye, everyone.